Good evening. We will start in next 2 minutes. Okay, so let us start. We will start with some questions. Question 1. Find Fourier transform of xt is equal to sgn t. So what is sgn function? Sgn means signum. Signum function is this is signum function. This value is 1, this value is -1. T is GNT function. Fine. So now it looks easy to solve the Fourier transform, right? So we have to find the Fourier transform of xt is equal to signum function t. And what is signum function? For t greater than 0, its value is 1, and for t less than 0, its value is -1. Fine. So we can write in mathematical form sgn t is equal to 1 for t greater than 0 and minus 1 for t less than 0. So mathematically we can write like this. Can we write it like u of t minus u of minus t? Yes, we can definitely write it. From here only we are getting this, right? Now, so we need to find, now the problem becomes to find the Fourier transform of ut and u of minus t, right? So now we will find the Fourier transform of ut first. Look again, signum function is means the value is 1 for t greater than 0 and minus 1 for t less than 0. So we are writing it mathematically. Signum is ut minus u of minus t. So now we know delta of t is its Fourier transform is 1. Now applying integration formula, okay, integration property we can say. So if we integrate delta t, we will get ut. Hope it is clear. So let us integrate minus infinity to plus infinity delta t delta tau d tau. Okay, now by integral formula we can write it. It's ft will be 1 upon j omega plus pi of pi into delta omega. How it is coming I will explain. Look, if there is a function x tau and we are finding Fourier transform of its integral, then it will be, if there is a function xt, its Fourier transform is x of omega, then minus infinity to t x tau d tau, its Fourier transform will be x omega upon j omega plus pi x of 0 into delta omega. Fine. And we are using this only. This formula we are using. Let us cut it rather than here. We can paste it here and with the box. Okay. So this is integral formula of Fourier transform. So using this formula, we can write x omega is 1. So 1 upon j omega, 1 upon j omega, pi is here. What is x0? Capital X0 at capital X0 is always 1, x value x omega is 1, so capital X0 is 1 and delta omega is delta omega. Fine. So from here we are getting this. Now what is the value of this? This is ut. So we are getting ut, its Fourier transform becomes this. One upon j omega plus pi delta omega. Now we have to find another Fourier transform. We have to find u of minus t, the Fourier transform of u of minus t. Simply we will use time reversal property. So let's write it again. Time reversal property. If xt its Fourier transform is x omega, then x of minus t its Fourier transform will be x of minus omega. Fine. This is time reversal property. So we will simply use it. So we get u of minus t its Fourier transform will be minus 1 upon j omega plus pi delta minus omega. And delta minus omega means delta omega itself. So we can write it equal to the same value, delta omega itself. So we are getting this. Now coming to the main problem. What was the SGN? SGN was ut minus u of minus t. So SGNT, its Fourier transform will be 1 upon j omega plus pi delta omega minus of 1 upon j omega plus pi of delta omega is equal to, this will be cancelled out and this will be summed up, right? So it is 2 upon j omega. So we got our solution, right? So please have a look on this. It was a very lengthy problem, although very simple problem. Our goal was to find the Fourier transform of SG and T, and we received the final result through the steps. Okay, hope you are getting understand. 2. Question 2. Find, I hope there is no issue till now with the previous problem. Fourier transform of 1 upon 3 minus jt. And to solve this, first we need to solve these few parts. Fourier transform of e to the power minus 18 ut. Why I am solving this? You will understand in later part. Okay, so Fourier transform of e of minus 80 ut, its Fourier transform will be minus infinity to plus infinity e to the power minus 80 ut e to the power minus j omega t dt. Fine. Is equal to, we can write it minus infinity to plus infinity e to the power minus a plus j omega t dt. Fine. If we integrate it, we will get minus e to the power minus a plus j omega t upon a plus j omega minus infinity to plus infinity. Okay, it will be 0 2, right? Because here it is ut, and in negative ut's value is 0. Ut means ut's value is 1 for t greater than 0. Okay, so we will get minus 1 upon a plus j omega into 0 minus 1. Okay, so we are getting 1 upon a plus j omega. Fine. Is it clear till now? Hope it is clear. So why we are doing this? Although the question is to find the Fourier transform of 1 upon 3 minus jt, but we are finding the Fourier transform of e to the power minus ut. Why? Because from here we will get the same form in frequency domain. And now what we can do, that is, we can apply duality principle. What is duality principle? Okay, so let us write it here. Duality principle is, if xt is Fourier transform is x omega, then capital Xt's Fourier transform will be 2 pi small x of minus omega. This is duality principle. Fine. So now we will use the same duality principle here. E to the power minus at ut its Fourier transform but we are getting 1 upon a plus j omega. So if we apply duality principle here, so we will get 1 upon a plus j t. Its Fourier transform will be 2 pi e to the power a omega into u omega u of minus omega, right? Okay, now if we apply time reversal property, have we introduced earlier? Yes, this is time reversal property. So time reversal property we will apply here. So 1 upon a minus gt, its Fourier transform will be Fourier transform will be 2 pi e to the power minus a omega u of omega. Okay, now put the value of a to get the answer. Put a is equal to 3, 1 upon 3 minus gt, its Fourier transform its Fourier transform will be 2 pi e to the power minus 3 omega u omega. So this is the solution. Now we will go to the next problem. Find Fourier transform of e to the power 3t u of minus t plus 2. We have solved earlier in earlier problem that e to the power minus at ut. Its Fourier transform will be 1 upon a plus j omega. So put a is equal to 3. E to the power minus 3t ut Fourier transform it is 1 upon 3 plus j omega. Now we need to use time shifting property. It is if xt's Fourier transform is a capital X omega, then small x t minus t0 is e to the power minus j omega t0 capital X omega. This is time shifting property. and we will use this here. So e to the power minus 3 t plus 2. Its Fourier transform will be e to the power j 2 omega 3 plus if there is any query please ask. 3 plus j omega. Now if we split it, we will get e to the power minus 3t multiplied with e to the power minus 6. Its Fourier transform is e to the power j2 omega 1 upon 3 plus j omega. Now multiply both sides with e to the power 6. Then we will get e to the power minus 3t here is u of t plus 2. Multiplied with u of t plus 2 its Fourier transform will be e to the power six plus j2 omega multiplied with 1 plus 3 plus j omega. Okay. Now apply time reversal property. Time reversal. So we will get minus t plus 2. Its Fourier transform is e to the power 6 minus j2 omega 1 upon 3 minus j omega. So this was the question. Find Fourier transform of e to the power 3t into u of minus t plus 2. And we are finding the answer step by step, right? Please see the answer. We will find one inverse Laplace now. Find inverse Fourier transform of this is minus a to plus a. It is 1. This is capital X omega and this is omega. So mathematically we can write capital X of omega is equal to 1 for minus a omega plus omega. So xt, anyone else is trying to join? Yes. Xt is equal to 1 upon 2 pi minus infinity to plus infinity x of capital omega e to the power j omega t d omega. So we can write it like 1 upon 2 pi minus a2 plus a x omega is 1, right? So it will be e to the power j omega t d omega is equal to 1 upon 2 pi e to the power j omega t upon j omega gt minus a 2 plus a is equal to 2 pi into 1 upon gt, and we can write it e to the power jat minus e to the power minus jat. So we can rearrange it like 1 upon pi t we will try to solve it. Jt minus pi t. Sin 80. So you understand that how we can calculate the value of xt. So please try to understand, take 2-3 minutes what we have done here from question 3. Please try to understand. Take 2-3 minutes and try to understand. You people try to understand from this question. This is very tricky question, right? Take 2-3 minutes and try to understand. Also try to understand this question, how we have solved, and if there is any query, please ask. Please take 2 more minutes to understand what we have done till now. Okay, so let us go to the next question. Five question. Okay, it was muted. You try to solve. You take 2-3 minutes and try to solve. How can we solve get the answer using Fourier transform? Okay, I will give you one hint that is we can use the solution earlier solution this question solution to get this. You think you take 2-3 minutes you take and think and try to do this. If you can do, just match the answer with my answer. If you cannot, then I will solve it for you. Have you got any answer? If no, then I will solve it for you. What we know, first thing, what we know. The basic definition of Fourier transform. A capital X omega is equal to minus infinity to plus infinity xt e to the power minus j omega t dt, right? Okay, now we have already received that sin 80 by pi t is inverse Fourier transform of this, right? So the Fourier transform of this Fourier transform of this will be this. So inverse Fourier transform of this is sin 80 by pi t. So the Fourier transform of sin 80 by pi t will be this one, right? So let us write sin 80 divided by pi t. Its Fourier transform is minus a to plus a. And this is 1. Okay, now now what will we do? We will replace xt here by this. So x omega, capital X omega is equal to minus infinity by plus in to plus infinity sine 80 by pi t e to the power minus j omega t dt. And this value is 1 for minus a omega to plus a. So it was omega x omega, right? Put now put a is equal to 1. and omega is equal to 0. So we will get x omega is equal to minus infinity to plus infinity sin t divided by pi t e to the power j omega t will be 1, right? So we will get dt is equal to 1 for minus 1, because we have put a is equal to 1, divided less than minus 1 less than omega less than 1 or plus 1, right? So we are getting this. So can we write that if we multiply pi in both sides, minus infinity to plus infinity upon t dt will be pi. Can we write this? It was what we have to find. So this is the whole solution. Please take a glance at this solution. You take 2 minutes or 3 minutes and have a glance. How we are solving this? First, we specify the basic definition of Fourier transform. Now we have used this property. We have solved this in earlier question, right? Now we have put xt value and then calculated in this way. You take 2-3 minutes and try to understand. You take 1 more minute and try to understand what we have done till now. Okay, so if there is no query, we will move to the next question. If you have any query, you may ask. One very interesting question we will solve now. Find Fourier transform of okay. The question is little different. The Fourier transform is given. The Fourier transform of ht is given h omega is equal to 2 cos omega multiplied with sine 2 omega divided by omega. Fine. Find y0. Very interesting question. You people plus please try to do by yourself first. At least can you tell the process how we can proceed? You take 2 minutes, think and then tell. At least one of you should tell. Not the whole answer, but the process how we can proceed towards the solution. Take 1 more minute and try to understand how we can solve this. Okay, if you cannot find the process to solution, I will do it for you. First, h omega is given. What is that? 2 cos omega sine 2 omega divided by omega. Okay, now we know a simple answer, cos A sin B formula, right? What is that? That is 1 upon 2 sin A plus B minus sin A minus B. Is this clear to everyone up to this step? Cos A sin B, right? Cos A sin B is half sin A plus B minus sin A minus B. Now we will use this to break this one. So cos omega sin 2 omega is equal to half of sin 3 omega because omega plus 2 omega, right, minus sin 2 omega minus omega, no, omega minus 2 omega, that means sin minus omega, and sin minus omega is equal to sin minus of sin omega, right? So we will get half sin 3 omega plus sin omega. Okay, so now H omega is, now what is H omega? Now what is H omega? That is important. It is we multiply 2 upon omega with this, right? So simple, we have used the formula cos A sin B, and cos to break cos omega sin 2 omega. So if we multiply 2 upon omega, 2 will be cancelled out. We will get 1 upon omega. Sin 3 omega plus sin omega. Is it clear till now? Till now we haven't proceeded to ht, small ht. We are, whatever we have done till now, that is capital H omega, that means the frequency domain. We have break it. We have broken this. Okay, fine. Now what will be ht, small ht? Small ht is 1 upon 2 pi minus infinity to plus infinity h omega e to the power j omega t dt d omega. Fine. So what is h0? Put t is equal to 0. What will we get? Put t is equal to 0. h0 is equal to 1 upon 2 pi minus infinity to plus infinity h of omega e to the power 0, it will be right. So 1, its value is 1, simply d omega. Now put the value of h omega. Of h omega. Okay, so ht h0 rather 1 upon 2 pi 'minus infinity to plus infinity 1 upon omega sine sine 3 omega plus sine omega. D omega. Now can we rewrite this as 1 upon 2 pi one upon 4 pi. Anyone wants to join? And it will be minus infinity to plus infinity 2 upon omega sine 3 omega plus minus infinity to plus infinity 2 upon omega sine omega d omega. Okay, here I haven't tried d omega, right? Plus. Fine. Is it clear till now? Take 1 minute and digest what we have done till now. Okay, now please mark this. We will come back to here. Now we have a general solution, right? We know minus a 2 plus a 1 t xt. If this is our time response, then it's a time domain signal. Fourier transform will be x omega is equal to 2 upon omega sine a omega. How we are getting this? So we have solved it in earlier session. Should I solve it again? Should I solve it again? Okay, then we are skipping the solution. We know this, so we can now, what is xt? Xt is equal to minus infinity to plus infinity x omega, here it will be 1 upon 2 pi. E to the power j omega t d omega. This we know. This is definition of inverse Fourier transform. The definition of inverse Fourier transform. Okay. t is equal to 0, then x0
Comment number 15. The work contains numerous symbols and acronyms.
is equal to 1 upon 2 pi minus infinity to plus infinity.
No, sir. Actually, it's not only symbols are normally
x omega d omega.
okay.
Now, if x omega is this, then
I have actually also
x0
in the paper where it is okay first, but still they have
put
written such as substitute this and the function
value
x hat over p and the function even if it is like defined there, but still. Yes, the comment says in section 3, the authors introduced new symbols that were not previously presented, such as the subsequent k given elements
so
of the
x0
global x hat over p. But sir, it was already defined there.
is
Not
equal
k
to
given I have not defined, but this
1 upon 2 pi minus infinity to plus infinity. What was the value? 2 upon omega sine a omega.
Yes, sir.
Okay.
So, okay, after calculation,
D omega as it was.
okay. Epsilon. It means normal distribution is what we have to use.
Now x0 is 1, so we can write 1 is equal to 1 upon 2 pi
And
minus infinity to plus infinity
okay.
2 upon omega sine a omega
Not x hat and p.
d omega, or we can write minus infinity to plus infinity 2 upon omega sine a omega
Yes, sir. After equation 10.
d omega
Actually, this
is equal to 2 pi. This is something we achieved. Okay. So now come to here. Here's similar type of equations we are getting. So
yes, sir, I checked it.
put
Normal in x. Yes. So, this is
a is equal to 3 minus infinity to plus infinity
first
2 upon omega sine 3 omega. t omega is equal to 2 pi, because it doesn't depend upon a, and put a is equal to 1.
I changed. Oh, yes. In comma. Yes, I wrote that. That is updated.
Is equal to 2 pi. So h0 is equal to it was 1 upon 4 pi.
Yes, sir. That's it. So we have to write x delta m this
Minus
we need
infinity
to
to
write
plus infinity
noted. Okay.
2 upon omega sine 3 omega d omega plus minus infinity to plus infinity 2 upon omega sine omega d omega is equal to 1 upon 4 pi this value is 2 pi plus another 2 pi, right? So finally we are getting 4 pi upon 4 pi is equal to 1.
So let's
So h0 is equal to 1. Is it clear till now? Take 2-3 minutes and try to understand what we have done till now. How we have achieved this answer. Take 2-3 minutes and try to understand. Take 1 more minute, 1 or 2 minute more to understand the solution, and then we will prove this again, okay, for your convenience. Take 1 more minute and try to understand. If you have any query, you can ask. Because this solution was very big, right?
But there is no question. What's that? Yes, sir. In the earlier versions when we had submitted so then there we had explicitly mentioned these things. But here we explicitly focused on filter and battery. So very less thing on test. There is mentioned test. Yes, sir. Where mentions are here by descriptor systems described by descriptor.
Okay. So let us prove it again in this question. This question number 7. Find Fourier transform of minus a to plus a t xt. Fine. So let us try to solve. If this is xt, if we write it, okay, xt here we have written. Xt is equal to 1 for minus a to t less than plus a. Zero elsewhere. Okay, fine. So now x
Yes.
omega.
Actually, sir, this package have included
From the definition of Fourier
huge package
transform,
changes because when we send them the LaTeX version, it will be very difficult for them to change that use color blue. So, for example, sir, this if I write here find, so on the top, if I write find the use package changes find, then all the blue color text will go away.
from the definition of Fourier transform,
So,
what is the basic definition of Fourier transform? X omega
if I remove those acronyms on the top now, automatically this spacing is
is minus omega to plus omega. Xt e to the power minus j omega t dt.
the same sub equations.
Okay,
Same is the sub equations. I have these all are sub equations. It's just because uh, the, the next equation 15 it has to come.
okay, is it clear? Fine. So is equal to
Uh, yes,
minus a to plus a.
section in section C.
Xt is 1. So e to the power minus j omega t dt equal to e to the power j omega t
Yes, sir. Actually, when I'm writing these integrals, when I'm saying we cannot
by
solve any matter.
the minus j omega
Also, I'm giving one method to solve. That's why again recalling.
from minus a
Sir, formatting you mean to say
to plus a.
so that is if it was
Okay,
bigger, then we would have kept
so we can write it as what we can write from here. It will be minus 1 upon j omega into e to the power minus j a omega minus e to the power plus j a omega, right? So let us write it.
then we can write it's like not like some equations. It's like equations.
e to the power minus j a omega minus e to the power j a omega. And incorporating the minus here inside, we can write 1 upon j omega
So this gives the final equation, right, in terms of answer calculated in the algorithm. I'm saying it's calculated in equation 20. Yes.
minus j a omega. And if we rewrite it like this, 2 upon omega
Okay. So that is in equation number
e to the power
30.
j a omega minus e to the power minus j a omega upon j2, and this is sine a omega, right? So this is 2 upon omega. So we got, if this is our time line signal,
Yes, sir.
minus a 2 plus a 1
Sir,
xt, its Fourier transform is 2 upon omega
okay, okay, sir. Then I have to
sine
for other.
a omega.
Yes, sir. Yes, sir. Okay.
Fine. So
Okay. Yes, sir. So
let us stop here.
sir, I should
We will
wait for
meet
both
on
you to
next
speak.
session.